On April 1st, 2026, 4 human beings climbed into a capsule named Integrity, sat on top of the most powerful rocket ever to carry a crew, and went to the moon.
Not to orbit it, not to photograph it from a distance, to fly around it, closer than any human has been in 54 years, and come home.
They traveled 252,756 miles from Earth, setting a record for the farthest distance humans have ever traveled in space. And in doing so, they answered the question the entire world had been quietly asking since 1972.
Are we actually going back? The answer, finally, undeniably, is yes. But going back to the moon is not a single act of bravery. It is a chain.
A chain of technologies, breakthroughs, partnerships, and choke points. Every one of them a problem that had to be solved before the next step became possible. This is the story of those choke points and how humanity cracked every single one of them.
Every journey to the moon starts with the same impossible problem: escaping Earth. Earth's gravity is not forgiving. To break free of it and reach the moon, you need a rocket of almost incomprehensible power.
For the Apollo missions, that rocket was the Saturn V, still one of the greatest engineering achievements in human history. It was retired in 1973. For 50 years, nothing replaced it.
Artemis changed that. The Space Launch System, SLS, is NASA's new super heavy lift rocket, designed to send the 4-person Orion spacecraft directly to the moon in a single launch. It is the only rocket on Earth that can do that.
And Boeing, who builds the SLS core stage, calls it the world's most powerful rocket stage. Getting SLS to the launch pad is itself a feat. The rocket and spacecraft must travel 4.2 miles from the vehicle assembly building to the launch pad. On a crawler transporter, the same crawlerway used by the Saturn V and the Space Shuttle, at a top speed of 1 mile per hour. Precision, not speed, is the language of the moon.
A rocket is a machine, but a mission is made by people. The Artemis II crew, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch from NASA, and mission specialist Jeremy Hansen from the Canadian Space Agency, completed humanity's first return to the moon in over half a century.
They named their Orion capsule Integrity. That word was chosen deliberately, because everything about Artemis depends on integrity. Of materials, of systems, of the thousands of engineers on the ground who built every component, with the knowledge that 4 human lives would depend on their work.
After splashdown, Commander Wiseman said, "Victor, Christina, and Jeremy, we are bonded forever, and no one down here is ever going to know what the 4 of us just went through, and it was the most special thing that will ever happen in my life." That is not the language of a test mission. That is the language of explorers.
You cannot walk on the moon in anything currently available on Earth. The moon has no atmosphere. Temperatures swing from 127 degrees Celsius in sunlight to minus 173 in shadow. Micrometeorites travel faster than bullets. The radiation environment would be lethal without protection. For decades, NASA's moonwalking spacesuits dated back to the Apollo era, modified, patched, but fundamentally unchanged. That was the choke point. You cannot go back to the moon in a suit designed for 1969.
NASA selected AxEM Space to develop a new lunar spacesuit, the AxEMU, and by February 2026, it had passed internal reviews and was undergoing final evaluation, with assembly of the first flight unit already underway. The AxEMU is not just an upgrade, it is a reimagining.
Greater mobility, better thermal protection, a helmet designed for the specific lighting conditions at the lunar South Pole, where the sun sits low on the horizon and casts long, deceptive shadows across the surface. Crack this choke point, and 2 humans can walk on the moon for the first time since 1972. This one is nearly solved.
Getting to lunar orbit is one problem. Getting from lunar orbit to the surface and back is another entirely. This is the lander choke point, and it is the most consequential unsolved piece of the Artemis puzzle.
NASA's Human Landing System program is working with SpaceX and Blue Origin to develop competing landers, spacecraft capable of transporting astronauts from lunar orbit down to the surface and back up again. SpaceX is developing a lunar version of Starship. Blue Origin is building a lander called Blue Moon.
Two very different approaches to the same problem. NASA is keeping both in play, because competition between two world-class teams is the fastest path to a solution that actually works.
Artemis II, launching in mid-2027, will test rendezvous and docking capabilities between the Orion capsule and one or both of these commercial landers, right here in Earth orbit, before the stakes of a lunar landing are in play. Test it close to home, prove it works, then go to the moon. That is the logic of exploration done right.
The Apollo missions landed near the lunar equator, the safest, brightest, most accessible part of the moon. Artemis is going somewhere the Apollo astronauts never reached, the lunar South Pole.
And there is a reason why. NASA's scientific instruments planned for lunar surface missions include sampling lunar water ice, and the South Pole is where that water ice exists, locked in permanently shadowed craters that have never seen sunlight in billions of years.
Water ice is not just scientifically extraordinary, it is operationally transformational. Water can be split into hydrogen and oxygen, rocket fuel, which means the moon's South Pole is not just a destination, it is a potential refueling station for missions deeper into the solar system.
A stepping stone, the first link in a chain that leads, eventually, to Mars. That is why this choke point matters beyond science. Crack the South Pole, and the economics of deep space exploration change permanently.
Apollo was a visit. Artemis is a settlement. Where the Apollo 17 crew spent 3 days on the lunar surface, Artemis aims to establish a base, extending trips to weeks and eventually months. NASA plans to begin building its moon base during Artemis V, with the goal of launching lunar missions once a year thereafter.
Building a base on the moon means solving problems that have never been solved before. How do you build structures where the temperature swings 300 degrees every 2 weeks? How do you protect humans from cosmic radiation when there is no magnetic field? How do you grow food in 1/6 of Earth's gravity? How do you manufacture the materials you need using only what is already there? These are the next choke points, and unlike the early ones, the rocket, the suit, the lander, these haven't been fully cracked yet.
They are the frontier, the open questions that will define the next decade of human achievement in space. The extraordinary thing is that solving them on the moon will also solve them for Earth.
Every material science breakthrough, every energy system innovation, every life support advance developed for a lunar base has direct applications for how we live on this planet. Going to the moon is not an escape from Earth's problems. It is one of the most productive ways to solve them. Everything Artemis is building, the rocket, the suits, the landers, the base camp, the supply chains, the life support systems, has a second purpose: Mars. NASA's long-term goals are unambiguous. Using the technology and research developed during Artemis, the agency intends to launch a future crewed mission to Mars. The moon is 238,000 miles from Earth. Mars, at its closest, is 140 million. The moon is a 4-day journey. Mars is a 7-month journey, minimum. Everything that fails on the moon, you can fix quickly. Everything that fails on the way to Mars, you fix alone, with the resources on your spacecraft and the ingenuity of your crew. That is why Artemis is not simply about the moon.
It is the most ambitious training program in the history of the human species. Every lesson learned at the lunar South Pole about radiation, about resource extraction, about living and working in deep space is a lesson that makes a Mars mission survivable. The moon is the rehearsal. Mars is the performance.
After splashdown, NASA Associate Administrator Amit Kshatriya said, 53 years ago, humanity left the moon. This time, we return to stay. That sentence contains the entire weight of what Artemis is.
Not a flag,
Not a footprint. Not a moment of national pride that fades in a decade. A permanent human presence beyond Earth. A base at the South Pole. Water ice turned into rocket fuel. A pathway to Mars. A species that has learned, finally, to live somewhere other than the planet it was born on.
Every choke point in this story, the rocket, the suit, the lander, the base camp, was a problem that looked impossible until someone decided it wasn't. That is the only pattern that matters in the history of human exploration. We are going back to the moon, and this time, we are not leaving.